In this section, we will understand the terms acids and bases. Some of you may be aware of the terms acids and bases, but we will look at the chemical aspect of compounds that are called as acidic. For example, the bacteria that turns the milk sour to make cheese or yogurt releases an acid called as butyric acid. There's another kind of acid that's present in your car's batteries, and that's sulfuric acid. What makes them both an acid, and why are they different? Because we do drink milk and it has butyric acid. However, do not drink this sulfuric acid that's present in the battery. It's really toxic. And similarly, there are bases such as ammonia, which is used for household cleaning as a base, and something like lye is also a base. But what are the differences between the two? So the first thing we want to do now is to know what are acids. And when we say substances that are acidic, we are generally talking about Alright, coming back to the terms acids. Acids are generally those substances that produce hydrogen ions in water. What that means is that many times an acid can be recognized if it has a hydrogen ion or hydrogen present in its formula. Now that may not always help, but that is usually the old concept of defining acids. So for example, up here we see the compound hydrochloric acid. I hope you remember this one. This is hydrochloric acid. The formula is actually given over here. I should actually erase that so it doesn't look too crowded. So the formula of hydrochloric acid is HCl. Now HCl has hydrogen and chlorine ions present in it. If it was ionized in water, which means that if acid was poured into water, then it would separate out the positive cation and the negative anion. This positive cation will accumulate in number within a solution, and then it will give it an acidic property. Now, because it has both kinds of ions, acids are very good electrolytes. They are generally sour in taste. You shouldn't be tasting acids, but for example, citric juices or lemon has acidic properties. Another acid that you might be familiar with is vinegar. So these are substances that have an acidic pH in them, and they're sour in taste. It turns a vegetable dye called litmus red. There are two kinds of litmuses. One is blue and one is neutral. Acids will turn blue litmus to red. So if we have some in the labs, so when you come into labs, I'll probably show you these. Another feature that acids can do is they can neutralize a base. What that means is that a property of an acid can be counteracted with a property of the base. Now all of these are properties that you should really know for the acids that are all given in this little chart over here. Gives this some basic properties of acids and basic properties of bases. Now the one that I gave you was mainly the Arrhenius theories, which had to produce hydrogen ions. Their electrolytes are sour, they stain red colors, and it neutralizes the bases. Now we will go into the Bronsted theory in a little bit, but I just want you to know that this is the older definition of substances that are acidic in nature. So let's go on to the next slide. If acids are substances that produce hydrogen ion, bases on the other hand produce OH ions in water. So for example, look at the formula of two bases that are shown to you over here. One is KOH and the other one is sodium hydroxide. Both of these are bases because you can see that they have OH ion or the hydroxide ion in its formula. However, this is again the older theory, which is the Arrhenius theory, which says that bases produce OH ions. I will get you the newer theories in a little while. Bases are bitter in taste and they're chalky. For example, calcium carbonate would also be a base. They're good electrolytes because they also have anions, and they're usually soapy and slippery, so most of your soaps and detergents are bases. And lastly, they also neutralize the acids on the other hand. So here's a solution of a base added to water. Notice that the OH and the sodium ions are separated. You have the anion and the cation separated. Now I might be giving you some of these on your test to ionize. So just before I go on to the next slide, I want to give you an example. For example, if I give you a substance such as KNO3 and I asked you to ionize it, what does that mean? That when you're trying to ionize it, you need water, and it will separate out as hydrogen ions and the nitrate ion, which is the negative ion. So these are called as reactions which show ionization. Let's look at another one which is a little different. Let's see. Okay. Another one that I will do is going to have H2SO4. Actually, you know what? So that nobody gets confused, I'm going to go ahead and use the previous slide over here and use that reaction under the acids because it is an acid. I don't want anyone to get confused about that. Okay, so let's see. Coming back, we have sulfuric acid, and what happens if it ionizes? Again, ionization means that water should be present. Since there are two hydrogen ions in here, so in the first step, hydrogen will be separated out one of the ions, and the bisulfate ion will be the other anion. So this is showing you that one hydrogen is released. However, the bisulfate ion will go on and release another hydrogen ions plus the sulfate ion. So now what has happened? We have another hydrogen released at the second step. So a solution that has H2SO4 is going to have twice as many hydrogen ions as a solution of HCl. You can see that HCl has only one hydrogen to donate, so it will be like that. Now think of something like this, H3PO4. What would be the hint over here? How many hydrogen ions will be released from this product? I'll give you a moment. The number of ions that will be produced by H3PO4 is going to be definitely 3 because there are 3 hydrogen ions in here. There are 3 hydrogen present, and this will take place in or actually 3 steps. The first step will give you 1 hydrogen ion, you will have H2PO4, then second step will give you another hydrogen ion and HPO4, and in the last step you will get another hydrogen ion and the phosphate ion by itself. So these are ionization reactions that you should be able to do for either an acid or a base. Now let's look at the new concept, which is called as the Bronsted-Lowry theory. This is the more recent definition of an acid and a base. The Bronsted-Lowry theory changes the word produce to the term donate and accept. So acids are substances that donate a proton, which means that can release hydrogen to another compound. For over here, instance, we can see hydrogen chloride is donating a proton to water. So water is forming a hydronium ion, which is a positive charged ion, and the chloride ion is hence released over here. So this is a reaction that in which we see that water is acting as a base. Because why? Because water is accepting a proton. The acid is HCl because acids donate a proton. Now with this definition of acids and bases, many compounds were then explained better in many, for example, many compounds that are present in biological systems or many organic compounds were explained better with the definition of acids and bases relating to the Bronsted-Lowry theory. On the other hand, keeping a Bronsted-Lowry theory in mind, if we look at ammonia and water, we can see ammonia as NH3, the formula over here, I hope you can see it, NH3. Water is H2O. Now in here, look at on the other side, what it seems that the water has donated a proton, so water is now acting as an acid, and ammonia is the base because it has accepted and formed NH4. However, we do have hydroxide ion in solution, so the older definition of the Arrhenius theory is not incorrect either, because the solution that is basic will also have OH ions, and a solution that is acidic will always have hydrogen ions. That the words produce has been changed to donate and accept, and a lot of different compounds this way can result in a base, in the definition of an acid and base, so they can be classified as both.